Whether you're a journeyman welder or just getting started in a metalworking trade, it makes good sense to follow safe operating procedures when you're using cutting and welding equipment. Oxy-Fuel safety is what I want to talk to you about today. When you buy and use quality equipment, you've taken the first step towards safety and good performance. But ultimately, your safety and the safety of those around you depends on how you use this equipment. If you use your equipment correctly, you'll do a professional job with a maximum degree of safety and productivity. When you use your equipment incorrectly or carelessly, that's when accidents are most likely to happen. Safe use of equipment begins with understanding what the Oxy-Fuel process is designed to do and how the process works. So that's where we'll start today. There are 4 basic Oxy-Fuel applications: welding, brazing, heating, and cutting. Welding is the process of joining 2 pieces of metal by melting or fusing their adjoining surfaces. A filler metal is usually added to build up and strengthen the welded joint. Brazing is similar to welding, but here the metals are joined together using a filler metal that melts at a temperature below that of the base metals. Heating is a process used to anneal, case-harden, bend, or stress-relieve metal. Oxy-Fuel cutting involves heating metal to its kindling temperature, then cutting it with a stream of pure oxygen. To fully understand Oxy-Fuel processes, you must also understand the function of the gases used. Oxygen is needed to support any combustion, so it's a key ingredient in the Oxy-Fuel process. Oxygen is typically supplied in either liquid containers or in compressed gas cylinders. This is a typical high-pressure oxygen cylinder. The contents are pressurized to over 2,000 pounds per square inch. To safely contain this pressure, these cylinders are made according to very strict standards established by the U.S. Department of Transportation, and they should always be handled with extreme care. If this cylinder fell over and the valve was knocked off, you'd have the equivalent of a gas-powered rocket, one with enough force to go through a brick wall. So always keep cylinders safely chained and in an upright position. And keep these valve protection caps on when the cylinders are not in use. Materials that will burn under normal conditions will burn far more rapidly, even violently, in the presence of pure oxygen. See how this common shop towel burns when supported by atmospheric air, which contains 21% oxygen. Now watch what happens when I add 99.9% pure oxygen. Remember, this shop towel could be a shirt or a pair of pants or gloves. Never use oxygen to dust off clothes, blow out lines, or run air-powered tools, because under the right conditions, it could result in a fire or an explosion. Many fuel gases are used in the Oxy-Fuel process. Acetylene is the most commonly used fuel gas. Acetylene is an unstable gas and requires a special type of cylinder to safely contain the gas. Acetylene cylinders have a porous core which is saturated with liquid acetone. When acetylene gas is pumped into the cylinder, it's absorbed by the acetone within the porous core. This keeps the gas stable while under pressure. Under industrial guidelines, the maximum safe delivery pressure for acetylene is 15 psi. To minimize the chance of withdrawing acetone from the acetylene cylinder, no more than 1/7 of the contents should be withdrawn per hour. This acetylene cylinder contains approximately 300 cubic feet of gas, So using the 1/7 rule, I can use up to 43 cubic feet in the first hour and not withdraw acetone from the cylinder. This smaller cylinder contains approximately 150 cubic feet of acetylene, and I can safely use about 21 cubic feet in the first hour and not withdraw acetone. If additional gas volume is needed for a particular application, cylinders must be manifolded together like this. Remember, adequate gas volume is essential for the efficient and safe operation of all gas apparatus. Acetylene cylinders must always be stored in an upright position in order to keep the liquid acetone properly contained. There are many other types of fuel gases, such as MAP gas, a group known as the propylenes, natural gas, and propane. Each gas has specific burning properties, temperatures, and operating pressures, and each requires specific apparatus. For complete information about oxygen and fuel gases, cylinder care and handling, and appropriate equipment, talk to a gas supplier or refer to your safety and operator's guide. Now let's take a look at the components of a typical oxy-fuel system. This is a typical oxygen acetylene setup using a small heating torch. Pressure from the oxygen and acetylene cylinders is reduced to working pressure by the regulators on each cylinder. Cylinders should not be used without proper pressure-reducing regulators. The delivery pressure data for the selected tip or nozzle is found in an operation chart like this. Charts provide specific pressure and gas flow requirements for individual tip styles and sizes. Hoses carry the gases separately to the torch handle, where each gas is controlled by a valve. Before lighting, the valves are used to purge or clean out each line independently. The fuel gas valve is then opened, the gas ignited, and the flame adjusted. Then the oxygen valve is opened and the flame readjusted until the desired flame configuration is achieved. When you use the proper equipment and follow correct procedures, the oxy-fuel process can be accomplished safely. However, it is necessary to be aware of potential hazards, which, if ignored, can result in serious injury to the operator and damage to the equipment. Two potentially hazardous conditions are reverse flow of gas and flashback. A reverse flow condition occurs when fuel gas enters the oxygen stream or when oxygen enters the fuel gas stream. Reverse flow most commonly occurs when one cylinder goes empty during operation, creating an imbalance of pressure in the system. It can also be caused by a clogged or blocked tip. If reverse flow isn't stopped, gas can flow all the way back into the cylinders. If these gases are ignited within the system, it can cause equipment damage and personal injury. Reverse flow can be prevented by using clean tips, making sure that the flow of gases from the tip is not blocked, using recommended pressures, and installing reverse flow check valves. The reverse flow check valve is a safety device designed to allow gas to flow in only one direction, from the regulator to the torch. Since reverse flow check valves are mechanical devices, they should be routinely tested according to the manufacturer's recommendations to ensure they remain in proper working order. I want to emphasize that if ignition of mixed gases in the system does occur, a reverse flow check valve alone will not stop a flame from proceeding upstream. Flashback is a term used to describe the condition resulting from mixed gases burning inside the torch. One common cause of flashback is not supplying an adequate volume of fuel gas to support the demand of the tip. This condition is called starvation. When this occurs, the flame flashes back to the mixture. A flashback, if not extinguished immediately, will likely result in damage to the torch and other components of the system and could cause serious injury to anyone near the operation. Flashback arresters are devices which have a sintered stainless steel filter that extinguishes the flame and prevents it from moving upstream in the system. Flashback arresters may be installed between the regulator and the hose. However, since the hose itself contains a significant amount of gas, a torch-mounted flashback arrestor has been developed to prevent a flashback from entering the hose. Some Victor torches and torch handles, like this one, incorporate built-in flashback arresters and reverse flow check valves. With this device, protection against these hazards is always in place, and accessory check valves and flash arresters are not necessary. Remember, reverse flow check valves by themselves will not prevent a flashback. So it's a good idea to always use both check valves and flashback arresters in your system. It's also important to make sure that the workplace is safe. Accidents and fires are almost always the result of carelessness. Keep the work area uncluttered and especially free of combustibles. Always have a fire extinguisher on hand. And if you must work near combustibles, set up a shield to contain the sparks and the hot metal. And have someone keep a close watch on the area while you work. Make sure the work area has good ventilation. The oxy-fuel process can not only deplete oxygen from the work area, but certain applications create highly toxic fumes. This may require the use of special breathing apparatus. Remember, proper ventilation is a must. Now we're ready to set up our equipment. Safe equipment setup begins here at the cylinder valve. First, inspect the valve carefully for damage, particularly the seat and the threads. And if there's any oil or grease on the valve or cylinder, don't use it. Inform the gas supplier immediately. Oil and grease in the presence of oxygen can burn violently. Before attaching the regulators, crack the cylinder valve. Just open it a bit, then close it again. This helps remove any loose dirt or dust that may be in the valve. And this is a good time to start developing a very important safety habit. Always stand to the side opposite the valve port every time you open the cylinder valve. And make sure no one is standing in front of the valve port when you crack it. Here's a typical high-pressure industrial regulator. It reduces the high cylinder pressure to a usable working pressure. Never attempt to use a cylinder without a proper pressure-reducing regulator. It's important that the regulator be properly sized for the specific pressure and volume of the application. Before attaching the regulator to the cylinder, always give it a thorough visual inspection to make sure it's in good working condition. Pay particular attention to any damaged threads or seating surfaces, a dirty or missing filter, or the presence of oil or grease. If you find any of these things, don't use the regulator. Take it to a qualified repair facility for a complete inspection and cleaning. Regulator inlet connections are threaded differently, so the oxygen regulator can't be put on a gas cylinder or vice versa. You should never have to force the regulator nut to start the connection. And this is important. Never change the inlet connection. When attaching the regulators, make sure the wrench fits the nut properly. It's important to remember that specially designed regulators and inlet connections are required for cylinders with pressures in excess of 3,000 psi. Be especially careful when pressurizing the regulator. On regulators with an adjusting screw, such as this type, first release the tension by turning it counterclockwise till it turns freely. This places the high-pressure seat of the regulator in a closed position. Always stand to one side of the regulator so the cylinder valve is between you and the regulator. Now, slowly open the cylinder valve until maximum pressure is indicated on the high-pressure gauge. Then open the oxygen valve completely. Most oxygen valves are designed to seal only in the fully closed and fully open positions. The fuel gas cylinder valve should be opened a maximum of 1 turn. Remember, if the cylinder valve has a key, leave the key on the valve. That way the system can be shut down in a hurry if necessary. Welding hoses carry the gases from the regulators to the torch. Now these hoses are new, so they're easy to inspect. If the hoses are cut, worn, or damaged, or have oil or grease on them, they should be repaired or replaced. Welding hoses are usually color-coded, red for fuel gas, green for oxygen. The fuel gas hose also has grade specifications. Be sure to consult current regulations to ensure the proper grade of hose is being used. The hose connections have different threads. Oxygen hoses have right-hand threads. Fuel gas hoses have left-hand threads. The V-groove on the outside of the fuel hose nut indicates that it has left-hand threads. Attach the hoses and tighten with a wrench. Now it's time to purge the hose lines. This procedure reduces the chance of any foreign material entering the torch. Set the regulator at 3 to 5 pounds of pressure and run the oxygen through the hose for a few seconds. New hoses which contain manufacturing residue or a hose that's been stored improperly